Hello everyone. Today we are going to continue to look at completing the square, and we're going to look at three specific examples where completing the square becomes a little bit more complicated. First, we're going to take a look at an example where we end up with a decimal. So let's look at x squared plus 9x plus 1 equals 0. So here, to start completing the square, we're going to take our middle coefficient 9 divided by 2 and then square that number. So we're looking at 4.5 squared, which we could take a calculator out. Here we end up with 20.25. So notice in our previous examples, we were always working with integers. Here we have a decimal, so a non-integer. Completing the square works exactly the same when we have a decimal. We're going to go through the same process. We'll just be working with numbers that maybe are a little bit more difficult to work with. So 20.25 is our goal for what we want in the ones place. I'm going to start off by subtracting 1 from both sides. And then to get 20.25, we're going to add 20.25 to both sides. So we get x squared plus 9x plus 20.25 equals 19.25. Okay, so next we can rewrite this as a perfect square. The number that we're adding to x is going to be this e divided by 2 value here. So 4.5 is the number that goes inside of our perfect square. So x plus 4.5 squared equals 19.25. Next, we can take the square root of both sides. Cancels out the square on the left. We end up with plus or minus root 19.25. And then we can split this up into two situations. So x equals negative, and then subtract 4.5 in each one. Negative 4.5 plus root 19.25. Or x equals negative 4.5 minus the root of 19.25. Okay, and in future courses, we're going to look at how we can simplify this. So in this situation, we usually want to switch this to a fraction, and then we can take the root of the top and the bottom. For this class, we're just going to leave it in the square root form and just call that our answer for now. So here, if we end up with a decimal, it's okay. We go through the same process. We're just going to end up with numbers that aren't integers, but we can still solve by completing the square. So that's our first example. Let's go through another example. We're going to look at what happens when we have a coefficient other than 1. So, for example, let's say we have 3x squared plus 12x plus, let's say, 7.5 equals 0. So in order to complete the square, we need a leading coefficient of 1. So we need 1x squared in the front, not 3x squared. So what we want to do is divide everything in our equation by the leading coefficient, 3. So 3x squared divided by 3 plus 12x divided by 3. And when we have terms separated by addition, we can divide each one separately. And in fact, that's what we want to do. So divide all of these by 3. We end up with x squared plus 4x plus 7.5 divided by 3 is going to be 2.5. And now we have a leading coefficient of 1 up here. So that means we can go through the process of completing the square, as we saw in previous examples. So whenever we have a leading coefficient, we need to divide everything by that coefficient to get a 1x squared in front. Here, really quickly, looking at our middle coefficient, 4, we take 4 divided by 2 and square it to find our goal, which is 2 squared. So our goal is 4. So to end up with 4, what we could do is add, here I'm thinking about 2.5 plus 1.5 gives us 4. Plus 1.5, and we need to add that to both sides. And we can rewrite this as a perfect square. And finally, take the square root and then split it up into our two situations. X plus 2 equals plus or minus square root of 1.5. And split this up. So if we subtract 2, in the positive case, we get negative 2 plus root 1.5. Or x equals negative 2 minus root 1.5. And again, we could simplify this radical, the square root over here, but we're just going to leave it for now. So leading coefficient, that's not 1. We need to divide everything by that coefficient. If it was a negative 3, for example, we would divide everything by negative 3. The last example we're going to look at is what happens when we get a negative on the right side. So example number 3. Let's say we have the equation. Let's start off with another leading coefficient, negative 2x squared minus 6x. And then we'll subtract, we'll have minus, let's do minus 30 equals 0. So we can start off by dividing everything by that leading coefficient, dividing by negative 2. Negative 2x squared divided by negative 2 is x squared. Here we have to include the sign with the 6, so negative 6 divided by negative 2 is positive 3. Here we include the sign, negative 30 divided by negative 2 is positive 15. Again, in this case, we'll end up with a fraction, but that's okay. We have 3 divided by 2, or middle term divided by 2 squared. So that's just 1.5 squared, which gives us 2.25. So 2.25 is our goal. And we'll notice something different when we're completing the square in this case. Let's start off like we did in our first example by subtracting 15 from both sides. And then we'll add that goal, 2.25, onto each side. So x squared plus 3x plus 2.25 equals, we get negative, I think, 12.75. And then we can write the left side as a perfect square. Again, that perfect square is going to be what we have when we take our middle coefficient and divide it by 2. So 3 halves, or 1.5. And then we'll take the square root of both sides, plus or minus. And notice we run into an issue on this right side, 12.75. Oops. That would make it okay. Here we have negative 12.75. So notice here we have a square root of a negative number, which gives us a number that is not real. So it's not in the real number set. Again, for Algebra 1, next year in Algebra 2, we'll talk a little bit more about complex numbers. So square roots of negative numbers. For now, we're just going to say that there are no real solutions. So if we end up taking the square root of a negative number somewhere while we're completing the square, we just say there's no real solutions. So that's kind of like the scope we're going to look at in this class, Algebra 1. So in this video, we looked at a few examples, what happens when we have a coefficient other than 1, when we end up with square root of a negative number, and as we saw first, what happens when we have a decimal while completing the square.